In this video lecture, we will see very important and interesting term optical activity in halogen derivatives. In our previous video, students we have studied chiral atom and molecular chirality. How to identify chiral carbon atom, what are conditions of chiral carbon atom, definition and concept of stereochemistry, definition of optical isomers. We also discussed that optical isomers are non-superimposable mirror images of each other, and optical isomers differs from each other by the measurable property, and that measurable property is called as optical activity. Optical means related to light. Therefore, few terms which are important to understand the optical activity that we have to discuss first. First term is ordinary light. Ordinary light is form of electromagnetic waves in which oscillations or these electromagnetic waves oscillates in all possible planes at the perpendicular from the direction of propagation. Second is plane polarized light. How plane polarized light is obtained? What is the meaning of plane polarized light? Plane polarized light is also the type of electromagnetic waves, and it oscillates in only one plane. The difference between ordinary light and plane polarized light is ordinary light oscillates in all possible planes. Plane polarized light oscillates in only one plane. How to obtain plane polarized light? When ordinary light is passed through Nichols prism. This Nichols prism is the other type of prism. One type of prism. After passing this ordinary light through Nichols prism, we get plane polarized light. Now we will discuss the concept of optical activity. This is plane polarized light in this figure. When plane polarized light is passed through sugar solution or lactic acid solution, when plane polarized light we discuss right now, it oscillates in only one plane. This plane polarized light we have passed through sugar solution or lactic acid solution. What happens when such plane polarized light is passed through sugar solution? It changes its rotation. We can see in this diagram, students, either rotation of that plane turns towards right hand side, or plane of rotation turns towards left hand side. Means when plane polarized light is passed through sugar solution, it changes its rotation, or sugar solution is kept in the path of plane polarized light, and we observe that this plane polarized light changes its rotation either towards right hand side or towards left hand side. So we can say plane of plane polarized light has rotated towards clockwise or according to clockwise or anti-clockwise. Students, such property of rotating plane of plane polarized light, property of rotating plane of plane polarized light, when it passed through a solution of a substance, such property of plane polarized light or such property of this substance is called as optical activity. Now I told you either clockwise direction or anti-clockwise direction, these two types have different meanings. When plane of plane polarized light is rotated towards right hand side or clockwise, it is said to be dextro-rotatory. dextrorotatory, and when plane of plane polarized light is rotated towards left hand side or anti-clockwise, it is said to be levorotatory. So dextrorotatory means right hand side or clockwise. Levorotatory means either anti-clockwise or left hand side. Dextrorotatory is denoted by small d or plus sign. Levorotatory is denoted by small l or minus sign. And the substance which rotates plane of plane polarized light, such substance is called as optically active substance. And there are certain substances which do not rotate plane of plane polarized light after passing through them. Such substances are called as optically inactive substances. Compounds which rotates plane of plane polarized light towards right hand side, such compounds are called as dextrorotatory compounds, and compounds which rotates plane of plane polarized light towards left hand side, such compounds are called as levorotatory compounds. And isomerism, in which optical isomers have different optical activity, are called as optical isomerism. And such optical isomers are of enantiomers. We know that enantiomers are non-superimposable mirror images of each other. Means they are two different compounds, but they looks like non-superimposable mirror images of each other. And students, enantiomers contains chiral carbons or chiral carbon, at least one chiral carbon atom in them. And we know that if compound contains chiral carbon atom in it, such compounds are optically active. One more remarkable thing of this optical activity, students, if we have two or more substances, two or more compounds which are optically active, or they are non-superimposable mirror images of each other, they are enantiomers of each other, their physical properties are same, like melting point, boiling point, refractive index, except their optical activity, their optical rotation, magnitude is same, but their direction is opposite. It means, suppose we have a lactic acid and its enantiomer or its mirror image, non-superimposable mirror image, then one molecule will show optical activity towards dextrorotatory, that is right hand side direction, and other molecule will show levorotatory, that is left hand side direction. Their direction will be different, but students, the angle by which they show their rotation, that angle will be same. And chemical properties of optical isomers or enantiomers is very similar because their chemical formula is same. The equimolar mixture of enantiomers, that is dextrorotatory and levorotatory substance of the compound, they are called as racemic mixture. Students, racemic mixture is new term for us. Racemic mixture is the mixture of enantiomers of same concentration, but means one substance is dextrorotatory and other substance is levorotatory. Their concentration is same. And remember students, racemic mixture is optically inactive. This is optically inactive because whatever effect is caused due to dextrorotatory substance, that effect will get cancelled due to levorotatory substance, because dextrorotatory substance will try to rotate plane of plane polarized light towards right hand side, and levorotatory substance of the same concentration will try to rotate the plane of plane polarized light towards left hand side. Therefore, each other's effect will get cancelled, and at end we get racemic mixture optically inactive. Therefore, racemic mixture is denoted by DL or plus and minus sign. Racemic mixture is denoted by DL, dextro and levorotatory, or plus minus sign in the bracket.